So we're going to go the opposite way. Now you have the graph of the original and the transform function. We have to come up with the equation. Well, each function has been transformed by either a stretch or a reflection. We're going to deal with b first, just because it's pretty obvious that that has to be a reflection. The original function was f of x equals absolute value of x. The reflection is in the y-axis. It's been reflected vertically. So to show that, we put the negative in front. Y equals the negative absolute value of x. Going back to A is obviously not a reflection, it's a stretch. The issue with stretches is defining whether or not it's a vertical stretch or a horizontal stretch. And to be completely honest, it doesn't matter which one you choose, so I'm going to go through both. If we deal with it as a vertical stretch, we need to look at some points and reference them. So I'm going to pick this point here that's at a height of 4. Its corresponding point on the new function is at a height of 12. Another point at, let's say, 6. Its corresponding point is at a height of 18. So if we deal with this as a vertical stretch, everything has been stretched out by a factor of 3. So we would call it y equals 3 absolute value of x. Just erase that so we can deal with horizontal. If we deal with it as a horizontal compression, we need to be a little bit more careful with the points we pick. If I pick this point that's at 4, my corresponding point is not exactly on a grid line, so it might not be the best point to pick. I am going to pick this point that's at 3. Its corresponding point is at 1. I have another corresponding point that's at 12. Its corresponding point is at 4. So everything has been divided by 3. And again, because it's a horizontal in this case, we treat it the opposite. Dividing by 3, otherwise known as multiplying by 1/3, we would actually put the 3 in there for it being the opposite.